Zaki binti Zamri, magnitude number S55105. According to American Bureau of Shipping 2021, methanol, alcohol or wood alcohol, is found globally and has been utilized for decades. Methanol is colorless liquid with a strong odor at room temperature and pressure, and it is easier to store and handle than LNG, ammonia, and hydrogen fuel. Methanol is often manufactured commercially from natural gas, but it will also be produced from renewable sources such as biomass or electrolysis, employing renewable energy and carbon capture utilization technologies. International Maritime Organization 2016 states that methanol may significantly emissions of reduced sulfur, NOx, particle, and greenhouse gas emissions. Methanol is solely used as a transportation fuel. However, maritime sector use it infrequently. The objective is to identify the impact of the application of methanol injection system in ships on the environment and human health. Second, to investigate the safety measures that need to be considered by the ship's crew and ship owners before applying the methanol injection system in ship. And lastly, was to analyze the challenges that may be faced by ship owners and crew in applying methanol injection system in ship. The background of the topic methanol is LCA involved from the discharge process from raw material extraction, fuel production, transportation and storage, bunkering, and finally on board. Environmental assessment of methanol use as ship fuel indicate methanol produced with natural gas has higher GHG emissions than conventional fuels, and methanol produced from biomass has the potential to significantly reduce emissions, provided the electrical energy used in the process is relatively clean. Evaluation of the readiness of methanol technology as a fuel indicates methanol fuel systems consist mostly of well-known components that involve individual components are technological nature. Next, it's requiring such methods technology as has been used in the maritime industry. Lastly, cost perspective. According to American Bureau of Shipping 2021, methanol is now more expensive than low sulfur marine gas oil (GO), which makes it a less attractive solution under the current regulatory landscape. In addition, the shipping industry is severely affected due to fluctuations in fuel prices, so the supply of methanol needs to be supported by contract measures that limit these fluctuations. That's all. Thank you.
Thank you to my friend Najwa Izzati. I will continue the next presentation. It's about case study related to fuel cell, methanol fuel cell. So Ida Nova methanol fuel cell test. Methanol fuel cell will be tested on board the Ida Nova cruise ships in 2021 to investigate the integration, efficiency, and operability of this fuel cell in relation to low emission liquefied natural gas (LNG) and battery generation options. So the fuel cells to be installed, designed and tested by the full dampered sealing technologies have been tested at offshore facility and are proven to have long lifespan of up to 35,000 hours of operations. So the test is also important basically to investigate the development of related energy networks, energy management, and the ecological and economic impact of the methanol fuel cell system. Second case study is about HIMAX ships, where a European consortium of 13 members has been working since 2018 for the purpose of developing a robust methanol vessel derived from the renewable energy. Using sustainable methanol produced on shore, HiMet ships applies onboard carbon capture system for the purpose of producing hydrogen and carbon dioxide. Hydrogen is then sent to a dedicated reciprocating combustion engine for power generation, and carbon dioxide is stored on board and returned to the offshore methanol production process. Therefore, a closed-loop process powered by renewable energy will be carbon neutral and completely emission-free. Typically, prior to installation on the ships, the technology will be tested at full scale on land. The consortium is working to ensure the system can be safely implemented using risk assessment while assisting with regulatory development for this type of novel system. Okay, next I will continue the next presentation about fall level awareness. In terms of fall level awareness, there are the evolutions of safety concepts in shipping. We'll cover fall level awareness, which is discovering, learning, understanding, and also developing. For this covering, the IMO actively call on its member country to reduce greenhouse gas emissions, GHG emissions, especially those involving the maritime industry, including transportation by sea. This is because high GHG greenhouse gas emissions have a negative impact on the environment and directly contribute to human health problems. Under discovering level also, beside the greenhouse gases emission also lead to a significant climate change, leading to natural disaster. Natural disaster cause many losses, threaten human health and safety, and even loss of life. Second level awareness is about learning. So greener shipping fuel has been identified as alternatives to reduce GHG emission from the maritime industry. This has led to the introduction of methanol as a more environmentally friendly and effective marine fuel alternative when compared to other marine fuel alternatives such as natural liquefied natural gas (LNG) and liquefied petroleum gas (LPG). Different types of marine fuel require a fuel handling system based on the type or characteristic of the fuel. This is because proper marine fuel handling systems are primarily concerned with safety, where every crew member should not compromise, especially with regards to safety. Therefore, the introduction of methanol as an alternative marine fuel led to the introduction of a special handling system based on the characteristic of methanol in an effort to turn it into a marine fuel. The next level is about understanding. So basically, methanol as a marine fuel report by Professor Karen Anderson and Chalmers of Chalmers University of Technology and Carlos is the project manager, has issued a report related to the use of methanol as a marine fuel involving in terms of regulation and compliance, methanol as a marine fuel engine conversion test, methanol fuel from an economic perspective, and moving to the market forward. In addition, there is also a study from the American Bureau of Shipping (MBS) related to sustainable white paper, methanol as a marine fuel and methanol as a marine fuel, environment benefit, technology readiness, and economic feasibility. The report issued by the International Maritime Organizations (IMO) also discuss the title and content that is more or less the same as other report related to this methanol. For the level of developing, taking into account and identifying previous level of awareness lead to the development of safety system related to methanol fuel injection system in ships. This is because the introduction of methanol fuel injection system in ships lead to the introduction of methanol fuel handling safety system that is adapted based on the characteristic of methanol, identified to be used as an alternative to marine fuel. IMO, International Maritime Organization, International Code of Safety for Ships Using Gases or Other Low Flash Point Fuel (IGF) code to provide mandatory provisions for the arrangement, installation, control, and monitoring of machinery, equipment, and system using low flash point fuel to minimize the risk to the ships, its crew, and the environment, having regards to the nature of the fuel. Personal protective equipment (PPE) when handling methanol may include but is not limited to chemical splash goggles and face shield, and then vital and neutral glove, anti-static rubber glove, chemical resistant coveralls, provision for supply fresh breathing air, multiple fire extinguishers, industrial first aid kits, water showers and eye wash stations, and lastly, supply of potable water for washing and drinking.
A risk analysis plan will be developed, reducing risks that cannot be eliminated and documenting the process. Loss of function, component damage, fire, explosion, and electric shock are all considered risks. In order to demonstrate an equivalent level of safety, the design must be complex and deviate from the prescriptive arrangement. Hazard identification, hazard and operability study, and FMEA provide valuable design recommendations. Common safety principles that consist location of fuel tank protection, double barrels on full supply line, ventilation and gas detection, classification of hazardous area, and explosion reduction. Generally, methanol will be used in ship after it has been approved and added to the IMO interim guidelines for the low flash point fuels in November 2020. For this purpose, liquid gas injection methanol have been developed for the purpose of high pressure injection of low flame point fuel of liquid such as methanol. It has a low fuel supply pressure and all high pressure pumping is done inside the injector. A booster fuel injection valve raises the injection pressure to 550 to 600 bar. This concept is used in the dual fuel engine which burns methanol on multiple methanol carriers. The system requires only minor modification to existing marine fuel infrastructure. The modification concerns methanol's low flash point. There are six key safety considerations that need to be emphasized as follows. First, methanol tank location. Next, methanol protection. Igniting and venting of a methanol tank, spill containment, vapor and fire detection, and lastly, firefighting.
Hello, my name is Elsie Anna Evistu. In the last section, I will explain the discussion and conclusion. Our group chose methanol for injection in ships as our topic for discussion, whereby I will describe the advantages and the disadvantages. In terms of advantages, the use of methanol as a marine fuel can reduce carbon dioxide emission. From an environmental point of view, the nature of methanol makes it easily biodegradable in environment involving aerobic and aquatics. The use of methanol has a less significant impact in the event of spillage and leakage into the environment when compared to conventional hydrocarbon fuel due to the characteristic that methanol is easily soluble in water. Methanol fuel has a strong potential to reduce the carbon footprint in shipment. In terms of these advantages, methanol with very high concentration in the environment carries a negative impact that can be fatal. Methanol in human body, either in gas or through absorption of oxidized skin, will produce formic acid and formaldehyde. Exposure to liquid methanol on the skin can result to irritation, dryness, cracking, inflammation, or burns. Excessive methanol exposure with a median dose consumed of approximately 100 milliliter will lead to death. In conclusion, methanol has been recognized as a future carbon neutral fuel if generated using biomass or biogas and renewable power. Directly, the manufacture of methanol from renewable biomass or biogas and power may help the IMO achieve decarbonation and reduce GHG emission. Overall, methanol distribution and engine availability lags behind natural gas, but the experience of large commercial ships suggests that methanol is a credible rival for future marine fuels. The development of new safety system and procedure based on the sustainability of the methanol and methanol mixture characteristic identified in the risk assessment and concept. Availability of methanol technology, safety equipment for handling methanol, and availability of methanol as a marine fuel need to be considered. Methanol is currently more costly than low sulfur marine gas oil or MGO. The higher price of methanol reduces demand for methanol as a marine fuel, making this a less attractive alternative under the existing regulatory environment. Fuel price fluctuation also harm the shipping industry. Therefore, methanol supply must be supported by contracts that limit price fluctuation. That's all from us. Thank you.